In question 14, we have the digits P, Q, R, S and T, each of which is one of the digits from 1 to 5, and every digit gets used once. And we're told that these two numbers, PRT and QRS, are both prime numbers. Let's think about the end digits T and S first of all. Which of the digits from 1 to 5 can a prime number end in? Well, it can't end in 2 or 4 because then it would be even, and the only even prime number is 2, and these are 3-digit prime numbers. Similarly, it can't end in a 5 because then it would be divisible by 5, and the only prime number that's divisible by 5 is 5, and again these are 3-digit prime numbers. So the only options that leaves for T and S are 1 and 3. So it doesn't really matter which order we have these numbers in, so we may as well assume that T equals 1 and S equals 3. So now we have these two numbers, PRT, T is 1, QRS and S is 3. Let's think about this number QR3. We know that a prime number cannot be divisible by 3 unless it's 3, but again these are 3-digit numbers. So let's apply the divisibility rule for divisibility by 3 and see what happens. A number is divisible by 3 if and only if the sum of its digits is divisible by 3. So let's think about Q and R. If Q and R are 2 and 4 in some order, then the sum of the digits would be 9, and that would be divisible by 3, which is no good. If Q and R were 4 and 5, the sum of the digits would be 12. And that would also be divisible by 3, which would again make this divisible by 3, and that's no good. So in fact, Q and R have to be 2 and 5 in some order. So that means that QR3 is either going to be 253 or 523. You may recall from question 10 that 253 is not a prime number because it is equal to 11 times 23. So that means that the only option is to have QR3 being 523. And that means that R equals 2. And that means that PR1 equals 421. And I'll leave you to convince yourselves that 523 and 421 are indeed prime numbers. But R equals 2 is our answer.